Hello everyone, in this video we will discuss what integration testing is and its different types. So let's get started. Nowadays, software is built using microservices architecture, which consists of several microservices that handle different components of the application. In integration testing, we check whether these different components or services of the application are communicating with each other properly or not. Imagine a hospital management system where different microservices handle various tasks. One service manages patient records, another handles appointments, third manages billing, and fourth manages notifications. A fifth service manages authentication, and so on. Each microservice might work properly on its own and would have been tested individually in the first level of testing using unit tests. Now, in the second level of testing, that is integration testing, we need to check if these services can work together to create a seamless experience for the user. For example, when a patient books an appointment, the appointment service should notify the billing service to generate an invoice, and a notification service should send a notification to both patient and doctor. If this communication does not happen properly, the system could fail. Integration testing ensures that these different microservices or components are connected together and work together smoothly. It's important because if these components don't integrate well, it means there are issues in the application which need to be fixed before proceeding further in testing. Also, integration testing helps maintain a quality of the software in the long run. Suppose we tested the application and released it to the customer, and a few years later a new requirement came in, leading to changes in one service. Integration testing will help ensure that even after these changes, the communication of the service still works fine with the other components. That's why teams generally aim to automate the integration tests. Now, there are four types of integration testing. First, Big Bang integration testing. Second, top-down integration testing. Third, bottom-up integration testing. And fourth, sandwich integration testing. Let's discuss each type one by one. Big Bang integration testing is when you connect all the software components at once and test the entire system together. For example, in our hospital management system, we have a total of 6 microservices. Instead of testing the appointment, authentication, and billing systems separately, we can link all 6 components or services with each other at once and do the integration testing. This type of testing is called Big Bang integration testing because we are making a big bang by integrating all the components at once and testing them together. Big Bang integration testing can help find big issues quickly, but if something goes wrong, it's hard to figure out what is causing the problem. That's the main disadvantage of this type of integration testing. That is Big Bang integration testing. For instance, if a patient booked an appointment and paid the money, but the billing failed, it could be an integration issue between the service or something deeper like a database problem or so. Pinpointing the exact root cause of an issue found in Big Bang integration testing is quite hard when everything is integrated at once. That's why some teams prefer other types of integration testing, such as incremental integration testing. The incremental integration testing has 3 different subtypes: top-down integration, bottom-up integration, and sandwich or hybrid integration testing. All these 3 types of incremental integration testing rely on the fact that all components of microservices are organized in a layered way. There are few services that only communicate with the services at the second level, and the services at the second level communicate with the services at the third level, and so on. For example, in case of hospital management system, at top level, there is one service, the user interface, which integrates two services at the second level. That is the authentication service and appointment booking service. These two services at the second level communicate with the third service from the next level. There is also direct communication between the top UI service and the services at third level or services at lower level. Basically, services at level n-1 will communicate with the services at n level only. Now, based on this assumption, the next types of integration testing are designed. Let's look at each one of them. The first type of incremental integration testing is top-down integration testing. In this approach, we test the higher level modules first, gradually adding lower level modules or services. For example, in a hospital management system, we start by testing how a patient books an appointment through the user interface only, as the UI service communicates with two services at the lower level, the authentication and appointment booking service. Instead of using the actual lower level services, we will use stubs for authentication and appointment booking services. These stubs are simple placeholders that simulate the behavior of the actual service. They will receive a request like the actual service, but instead of doing any complex work like database lookups, they will just return hard-coded values. However, the response format and protocol for these would be same as it would be in the actual service. For example, when a patient sends a login request through the UI interface and it goes to the stub of the authentication service, the stub will check it against the hard-coded values and return the response. The response will be in the same format as the actual authentication service. The UI service will think it's getting a response from the actual authentication service, but it's really coming from the stub. Once the testing team confirms that the UI service works fine with authentication and appointment service stubs, they gradually replace them with real backend services. Then they start the integration testing of the next lower level services like patient records, billing and notifications. This time they will use the actual services for the UI authentication and appointment services, but stubs for the lowest level services like patient records, billing and notifications. Once this level is tested, they will move to the next level and integrate the next set of services. This way, they start from the top and then go down to the bottom in an incremental manner, continuously integrating the services for testing. That's why this approach is called as top-down integration. The benefit of top-down integration is that it helps catch the issues early. You start with the parts of the system that user interacts with the most. So any critical issues in the user experience are caught early. Also, it's easier to debug and find the cause of the issues compared to the Big Bang integration testing. However, there is also a downside. You need to create stubs for services that aren't ready, which adds extra efforts and can slow things down. Then comes bottom-up integration testing, the next type of incremental integration testing. This is the opposite of the top-down approach, where you start testing at the lower level of services first and then move upwards to the higher level of services. Imagine a hospital management system and its hierarchy of modules that we discussed in the previous section. In this approach, we start the integration testing by verifying how the patient records, billing and notification services communicate with the next level up, such as the authentication and appointment booking services. Instead of using the actual high-level services at this stage, we will use the drivers to simulate the behavior of the high-level services, such as the authentication and appointment booking services. A driver is like a temporary substitute for a component or a service, and it is useful in testing a lower level module. Think of it as a tester module that provides the necessary inputs to the module you are testing. For example, in this case, we are testing the billing service, which depends on higher level services like appointment booking. So instead of using the actual top level service for appointment booking, we can use a driver that simulates the input to the lower level service like billing, allowing us to test the billing service in isolation without the actual appointment booking service being ready yet. Once we are satisfied that the lower level services are working fine and communicating correctly with the drivers of higher level service, we will move upwards to the next level. At this point, we will replace the drivers with the actual authentication and appointment booking services. But this time, we will use driver for top level service, that is UI service. Here, we are testing whether the mid-level services are integrating properly with the top-level service or not. Once we complete the testing at that level, we will incrementally move up and use the actual UI service instead of the driver. Now, let's talk about sandwich or hybrid integration testing, which is the next level of integration testing. Hybrid integration testing combines both top-down and bottom-up integration testing approaches. It's like testing from the middle where higher and lower modules are integrated and tested simultaneously. For example, in a hospital management system, you might integrate and test the high-level service such as user registration and low-level service like billing, patient record management and notification service at the same time. This approach helps speed up testing by allowing you to focus on different parts of the system at once, ensuring smoother integration between the layers. So these were the different types of integration testing. Integration testing ensures that all the microservices in the system work together properly, avoiding any hiccups that could impact the system's performance or quality. Whether you test everything at once using Big Bang or you do it step by step using top-up or bottom-up approach, the goal is same, that is to ensure that all services work together seamlessly. So that's all for this video. Please do not forget to subscribe the channel. Bye for now, and if you like the video, please send a comment.